Have you ever paused to ponder one of life's biggest mysteries? What happens when we die? Throughout human history, this question has sparked endless debates, shaped cultures, and inspired entire belief systems. Yet amidst all the speculation, one fact remains: death is a phenomenon shared by every living creature. In this documentary, we set aside speculation and turn to science, the fields of biology, neuroscience, and medicine, to explore this final frontier. Relying only on real, measurable evidence, we'll demystify what happens when we take our final breath. This is not merely a philosophical journey. It's an evidence-based examination of death as a natural process, an experience rooted in the laws of nature. Let's begin by understanding what we know for sure about this universal event. To explore what happens when we die, we must first define death. Today, medical professionals distinguish between clinical death, when the heart stops beating, and biological death, where all cellular function ceases and the body begins to decompose. Clinical death is often reversible with timely medical intervention. For example, cardiopulmonary resuscitation, CPR, or defibrillation can restore a heartbeat shortly after it stops. However, biological death marks the point of no return. Without oxygen and energy, cells begin breaking down irreversibly, leading to the cascade we recognize as death. In a clinical sense, life and death are separated by a very thin line. But what exactly happens during those critical moments when the body shuts down? Imagine the body as a highly synchronized machine. When a key component like the heart stops working, everything else rapidly follows. When the heart ceases pumping blood, the oxygen supply to tissues and organs is cut off. The liver and kidneys are among the first to fail, quickly followed by the brain, which is highly oxygen dependent. Within minutes, the lack of blood flow triggers cellular death on a massive scale. The brain undergoes a fascinating process during these moments. Studies show that during the transition to death, the brain releases a flood of neurochemicals, such as serotonin, creating vivid hallucinations and intense emotional responses. This could explain why many near-death survivors recall feelings of peace, seeing a bright light, or experiencing life flashing before their eyes. These neurochemical surges may not be evidence of an afterlife, but rather the brain's natural response to its failing state. A particularly intriguing phenomenon is the near-death experience, reported by individuals who have flirted with the edge of biological death and returned. These accounts often describe floating sensations, out-of-body experiences, or encounters with loved ones. But how does science interpret these claims? In controlled studies with patients surviving cardiac arrests, neuroscientists have measured fleeting, synchronized bursts of brain activity moments after the heart stops. These heightened states of awareness may explain the vivid clarity of near-death experiences, suggesting they are likely byproducts of the dying brain rather than evidence of something supernatural. Another scientific explanation for NDEs is hypoxia, or oxygen deprivation in brain cells. When neurons struggle for survival in low oxygen conditions, perception becomes skewed, often triggering vivid imagery or feelings of detachment from the body. While near-death experiences fuel cultural fascination, they remain firmly rooted in the physical and chemical processes of the brain. Another reminder of just how tightly death is intertwined with life's biological systems. One of the most debated questions is whether human consciousness exists beyond biological death. Does awareness survive in some form, or is it entirely a product of brain activity? Consciousness refers to the state of being self-aware, formed by the interactions of billions of neurons firing in the brain. During and after death, when brain activity halts, most scientists agree that consciousness also ceases. Interestingly, some studies have recorded brief moments of awareness in patients revived after cardiac arrest. Individuals have recounted auditory memories, hearing doctors discuss their condition, for instance, even after being declared temporarily dead. While these cases suggest lingering brain activity during clinical death, there's no conclusive evidence to suggest consciousness persists after biological death. Instead, they highlight the brain's remarkable ability to function, even under extreme stress, within a narrow window of time. After death, the changes in the body become more apparent. These natural processes are a stark reminder of the biological cycle of life. Within moments of death, the body undergoes noticeable transformations. Breathing stops, skin pales, and rigor mortis, the stiffening of muscles, sets in within hours. With no oxygen, cells lose their integrity and burst, triggering decomposition. The body's natural bacteria, particularly in the digestive system, begin breaking down tissues, releasing gases that contribute to bloating and odors commonly associated with decay. From an ecological perspective, decomposition is essential. Nutrients released during the breakdown of organic matter become valuable resources for other living organisms, perpetuating the cycle of life even in death. One of humanity's greatest scientific achievements is pushing the boundaries of life and death. With modern medicine, techniques like cardiac resuscitation can restore life to individuals who would otherwise have been considered irreversibly dead just decades ago. Tools like CPR and defibrillators work to restart the heart, while hypothermia therapy slows cellular death, buying valuable time for interventions. These advancements reveal the resilience of the human body and the ability to defy death, temporarily at least. However, resuscitation has limits. Beyond approximately 10 minutes without oxygen, the brain sustains irreversible damage. While miracles do occur, they are the result of quick and effective medical responses. These advancements also raise ethical questions. Should all life be prolonged at any cost, even when quality of life cannot be guaranteed? As we push closer to understanding death, these moral considerations remind us of its profound complexity. Despite decades of research into death, some questions remain tantalizingly unanswered. For instance, while we know the brain generates consciousness, understanding exactly how subjective experiences emerge from neurons remains a colossal challenge. This hard problem of consciousness is one of neuroscience's biggest mysteries. Scientists also acknowledge the limitations of measuring death's subjective experiences. For instance, how do we account for accounts of vivid recollections moments after declared death? Are our current tools for measuring brain activity sufficient to capture the mystery of consciousness at these critical moments? The more we study, the more we realize how much there is left to learn. Death is more than a medical event. It's an experience that has shaped human culture for millennia. Adding perspectives from multiple disciplines enriches our understanding of its significance. Doctors routinely navigate the line between life and death. Their insights into how and when to fight for life and when to let go underscore the importance of treating death as a natural, inevitable process, rather than solely a failure of medicine. Neuroscience sheds light on how the brain orchestrates the process of dying. Researchers studying near-death experiences and consciousness hope their findings can improve end-of-life care by providing clarity and comfort about this universal experience. From a psychological standpoint, death represents a profound emotional challenge. Our awareness of mortality deeply impacts how we live, influencing everything from the way we form relationships to how we search for meaning and purpose. In nature, death isn't the end, it's a continuation. The transformation of organic material nourishes new life, sustaining ecosystems for future generations. Species that embrace death, adapting their life cycles to include it, demonstrate resilience that transcends the individual. For humans, this perspective provides a valuable lesson: to approach death not merely as an ending, but as a process that connects all living things. While our exploration may not fully answer what happens when we die, we've uncovered remarkable insights. Science has revealed death as a chemical, biological, and neurological process, one tied intrinsically to life itself. By examining the measurable evidence, we've demystified many aspects of death, from the physical decay of the body to the fleeting moments of heightened brain activity. And though profound mysteries still remain, this journey invites us to embrace curiosity, not fear, in the face of the great unknown. As curious learners, we may never know all the answers, but in seeking evidence-based truths, we find a deeper appreciation for existence. Death, it seems, is not just an ending, but an integral part of life's story.